Hi everyone! In this video we will graph a linear inequality. Graph the linear inequality y is less than or equal to negative 1/2 x plus 3. This is in slope-intercept form. The slope is negative 1/2 and the intercept is positive 3. So we're going to go to the y-axis and find the intercept at positive 3, 1, 2, 3. And we'll put a dot here, that's where it intersects. Now from here, we'll use our slope to count rise over run. This means that I need to rise -1 from my y-intercept. So to rise a -1, that means we need to move down, so that's the up and down. And then we need to run a +2, that means going to the right +2, and this will be the next point in our line. We can also move the negative to the bottom so that we have a rise of +1 and a run of -2. So if we start again at our y-intercept and then we rise a +1 and then run a -2, this goes back to the left 2, you'll notice that it still ends up on the same line. Now we need to connect those for our boundary line, and because we have a less than or equal to, this means that the boundary line is solid. If it was just less than or greater than, then it would be a dotted line. Because ours has an or equal to, that means that the boundary line is solid. Now we need to know if we shade above or below. To do this, we use a test point. And my favorite test point is the origin of 0, 0. This means we substitute 0 in for x and 0 in for y and see if it gives us a true statement. So we'll have 0 is less than or equal to -1/2, substituting 0 in for x, plus 3. 0 on the left doesn't have any operations, so it's still just 0. Is less than or equal to -1/2 times 0 is 0, plus 3. 0 plus 3 is 3. And we end up with a statement that says 0 is less than or equal to 3. This is true. 0 is less than or equal to 3. This means that our test point of 0, 0 should be included in the shaded region. So this means that we will be shading down here to include the 0, 0. So we'll be shaded down here. If we had gotten a false statement, this would mean that the test point should not be included, in the shading, but because ours is a true statement, it should be included in the shading, and all of this is shaded in because the 0, 0, or the test point that we chose, is a solution, so it should be included in the shaded region of all of the solutions. There is a shortcut to know which direction to shade for an inequality, and it only works if it is in slope-intercept form, meaning that the y is all alone on the left side of the inequality. In this case, it is on the left side, so it is in slope-intercept form. If that is the case, then we only need to look at the inequality. A lesser than sign means that we shade below or to the left, and a greater than or equal to means that we shade above or to the right. In this case, we have a lesser than sign. This means that we shade below the boundary line. Had we had a greater than or equal to, we would have shaded above the boundary line, and it would have been shaded up here. But because ours is a lesser than sign, we shaded below. So this is not correct, and this is. And we're all done.